Your Majesties, Your Royal Highnesses, Laureates, Ladies and Gentlemen. Det är en stor ära att få presentera Nobelpristagaren i fysik. It is a great honor to introduce the Nobel laureate in physics, Professor Emeritus Peter Higgs.
What is the Higgs boson?
Well, like all in elementary particles, I think we field theorists think of it like Einstein thought of photons as just these particles are just packages of energy of some kind of field. And the feature which distinguishes this kind of theory, which leads to this kind of symmetry breaking, is the existence of what we theoretical physicists call the vacuum, which means nowadays something different from what it used to mean. It means just the lowest energy state that you can possibly have, in which there are no particles around, but there may be something around, and that something around can be a background field of some sort, which pervades the universe. So in this theory, there is such a background field, and the background field, in interaction with all the other stuff which goes through it, is responsible for generating the masses and mass differences of the other particles, elementary particles, the ones which are packages of energy of all the other fields, simply because the background affects the way the waves propagate. But then the field itself can be excited or classically to give you waves, and the packages of energy of that are the Higgs boson. So it's an extra which comes with this type of theory, that you need to have something there which is the excitation of the background field.
So how would you verify this idea through experiment? Well, here's one possibility, the one that has actually been done. Take particles, make them go around, say, the Large Hadron Collider near the speed of light and slam into each other. When they slam into each other, they kind of are banging into space. They're kind of slapping space. They're kind of spanking space. And when you spank space, if it really is filled with this molasses, then the molasses should kind of jiggle. And if you jiggle the molasses in the right way, you should be able to flick off a tiny speck of the Higgs field, and that tiny speck would be a Higgs particle. And that, indeed, is what we believe has happened at the Large Hadron Collider. Very hard to find these particles. Calculations show that roughly 1 in a trillion of these spankings of space, these collisions of particles, will actually flick off one of these Higgs particles. But now there's very strong evidence that the Higgs particle has been found, that this Higgs idea is right.